Thank you, Sadikul, for your kind introduction. And good afternoon, all. I welcome you to this session. I am Dr. Akhtar Hussain. I belong to the Department of Chemistry uh, from Handique Girls College. So today I'm going to be talking about the role of chemistry and the wisdom of Indian knowledge systems. Uh, So basically, this is a fast topic actually. Indian knowledge system. It's a fast topic. So when it comes to chemistry, so I'm not sure how much I can do justice to the topic, but I'll try my best. I have tried my best to accommodate uh, the relevant information related to chemistry of the Indian knowledge system. So, what is the role of chemistry in IKS? So, chemistry has been deeply embedded in IKS practices, starting from fields like metallurgy and medicine to cosmetics and alchemy. I'll come to those things later on in detail. And there are concepts like Rasa Sastra, Bhashma, fermentation, herbal extraction, and material transformation. All these things actually reflect advanced chemical thinking from the ancient times in India. So basically, I'll try to see two things here today. So how did chemistry shape the ancient Indian practices and the scientific depth of Indian knowledge system and its potential relevance in modern times. So when you talk about chemistry, so if we see the picture here, so how important is chemistry? So we actually know that there is a subject like chemistry. So if you see the picture here, so chemistry is often referred to as the central science. So it is a central science. That means it is connected to all other branches of science. We can see different fields here, starting from chemical engineering, material science, nanoscience, physics, nuclear chemistry, geochemistry, environmental science, and all bunch of scientific branches where chemistry is somehow related. So that is the reason now the subject has been referred to as the central science. In fact, there is a journal in the American Chemical Society in the name of ACS Central Science. And also the chemistry has a very huge impact on human civilization. Okay, so let me just start this one. So I just want to give you some historical timeline of the chemistry in India. So how it actually started from ancient India to the colonial period. So in the pre-Vedic and Vedic period, so people knew how to use fire in rituals. Then they had so there were metallurgy references in Rig Veda, and there were those basic elements like Pancha Mahabhutas, earth, water, fire, air, and space. We know these things, Pancha Mahabhutas. And there were the concept of Rasayana. Rasayana means it's a combination of alchemy and rejuvenation therapy. I'll come to that later on. And in the classical period, there was a development of Ayurveda and alchemical practices. And we find the text like Saraka Samhita, which is the description of the Ayurvedic practices, and Susruta Samhita, which is a description of medical practices, and Rasa Ratnakara is a description of chemical aspects. And also we had the knowledge of extraction of metals like zinc and copper from the ancient times in India, and also that of the dyeing techniques and glassmaking skills. In the medieval period, if you see, then there was the growth of Rasa Sastra, and also there were the influences from the Unani and Persian alchemical knowledge, and people knew the method of distillation, sublimation, and the use of acids in metallurgical processes. And in the colonial period, if you see, then we find that the Western scientific influence to British education, then things were started to become more modern in the colonial period. And then there was the establishment of scientific institutions like IISc and Presidency College. And then finally, the integration of traditional practices with modern chemistry actually took place. Now, what is the core concept of Indian chemistry? So basically, there are some core concepts here. If we talk about chemistry in ancient India, there are some core concepts. One of the concepts is the rasa. Rasa means mercury, which is a central element in Indian alchemy. Rasa Shastra is the science of processing metals and minerals for medicinal purposes. Pancha Mahabhuta is the combination of five things like earth, water, fire, air, and space, and these five elements actually constitute matter. And there is the integration of chemistry, ancient chemistry, with Ayurveda. This is also a vast topic. Then there is a phasma science. We know that there is a concept like phasma. So phasma means it is a calcinated preparation. I'll come to that. Phasma. Then dhatus and loha, metallurgy is there. Then tantra and alchemy, rasa tantra is there, which is actually a spiritual dimension to chemistry, focusing on purification of body and soul. So overall, if we see from the ancient time, chemistry was viewed as both as a material and spiritual science. I don't know. Maybe that, yeah. Okay. Am I audible to the audience?
Yes.
Okay. I think there is some issue with if I play the this one display slideshow is not working.
Yes,
Okay,
not
no problem. Okay, so let me just explain what is the phasmas. So phasmas means it is now in a modern term, it is called the nanoparticles of ancient India. The phasmas are actually unique metallic and mineral preparations used in Ayurvedic medicine. So they are made through a traditional alchemical process, transforming heavy metals or minerals into a fine, bioavailable, non-toxic ash. The goal is to detoxify and enhance the medicinal value of the metals like gold, silver, copper, zinc, mercury, iron, and all sorts of metals. So, how phasma is prepared, or how phasma was prepared from the traditional in the ancient times. So, the first step is the shodhana, which is the purification or detoxification step. Here, the raw metals or minerals will be purified using herbal substances or liquids like cow urine, lemon juice, buttermilk, etc. And this step actually ensures the removal of toxic impurities and prepare the substance for the next step. And the second step is the marana, incineration, or it is also called calcination. Here the purified metal is ground with herbal juices and made into pellets or discs. And then these are placed in a sealed container, earthen container, known as Sarava Samputa, and subjected to intense heating in a pit, which is also known as furnace, using cow dung cakes as fuel. So the people extensively used cow dung cakes as a fuel in ancient times. And then this cycle is repeated actually multiple times. If, for example, if the metal is gold, if somebody is preparing gold bhasma, then this step is repeated at least say 100 times, even more than 100 times, depending on the metal and desired quality of the bhasma. And then third step is the vavana, which is called levication or wet grinding. And here between calcinations, the product is repeatedly ground with specific herbal juices to improve the medicinal properties and ensure fine particle size. And the last step is the amritikarana. This is an additional step, and it is needed for some specific metals like mercury, because mercury is normally toxic to the humans. So some additional purification step is needed, that is called amritikarana. So these are the basic steps in the preparation of bhasmas. And here I show some 4 examples of bhasmas. The first one is the most popular one, is the Sarna bhasma. We know that this bhasma is made up from gold, and it is actually, in general, this is expensive, and it is used nowadays also, and extensively used for rejuvenation, immunity, and nerve diseases, to cure actually nerve diseases. The gold bhasmas are widely available. Then Loha Bhasma is there. It is made up from iron and used for anemia and general weakness purposes. Then Tamra Bhasma is there. That is a copper. It is used for treating liver disorders. And then Avraka Bhasma is there. That is used. That is made up from mica, and it is also applied to cure respiratory health. And then comes the now there's what is Ayurveda and chemistry. There is a very strong linkage between Ayurveda and chemistry. So this is an ancient modern nexus now. And Ayurveda, as you know, is a 5,000 years old holistic science of life, and it emphasizes the balance of body, mind, and spirit, and it utilizes natural substances. We know all this. And the great thing is that it is now not, it is now a modern science. Ayurveda is a modern science now. Starting from the, it started in the ancient India, and now it is a modern science. And there is a, as you know, everybody I think is aware that there is a ministry called Ministry of Ayush. Ayush is a combination of Ayurveda, Unani, Siddha, and homeopathy. These four branches, and it is called the Ministry of Ayush. They actually oversee the entire thing called Ayurveda. And also, if you see, the chemistry is actually a mandatory curriculum in teaching and research in Ayurvedic institution. If you see the entire India, there are so many Ayurvedic institutions. The chemistry has been made mandatory in the teaching and research curriculum. So that the impact from this slide, you can see that the impact of chemistry is actually huge. So in Indian knowledge system. And now, what is the the role of this one? Chemistry in metallurgical in Indian knowledge system. One of the roles is the metallurgical chemistry. So if we see here, in the ancient times, people knew the techniques like smelting techniques in metallurgical processes, such as iron smelting, zinc distillation. So zinc distillation is one technique where if you go to Rajasthan, you will see that there is something called Jawar mines. This is a site actually where zinc, pure zinc metal was prepared by a distillation process. This is one of the very oldest mining sites, very well known for zinc purification of zinc by a distillation process. So in the ancient time, people had the knowledge, this chemistry knowledge, to how to purify metals. Then copper metallurgy is also there, and there is evidence from the Harappan sites. And then if we go to Delhi, you will see that Delhi iron pillar. It was built in the 4th century CE, and it is actually a rust resistance. You will see there is no rust actually. It was resistant to rust. That means in the ancient time, people knew how to make rust resistant metallic structures, as exemplified by this Delhi iron pillar here in the picture. And then people knew how to use plant-based fluxes and reducing agents. They had those empirical understanding of the oxidation reduction principles that is commonly taught in the school and undergraduate institutions in India, common oxidation reduction processes. And they also knew repeated thermal cycling and purification steps, reflecting modern metallurgical concepts. Overall, if you see that in the ancient time, people had those chemically advanced knowledge of metallurgy. And then this is another one, that is ancient alchemy. So alchemy is like a that is a kind of it is a kind of science. It is not perfectly science, but it is a kind of pseudoscience where people try to convert all the metals to gold, because gold is the most precious metal. Here the core philosophy is the Rasa Shastra, the science of mercury. Rasayana is the part of essence, leading to rejuvenation, longevity, transformation. Then the integration of medicine, metallurgy, and spirituality. The primary goal was to attain immortality. The alchemical goal was actually to attain immortality, which is known as Dehashikti, and perfect health. It was the transmutation of base metals into noble ones, for example, mercury to gold, and achieving spiritual liberation, moksha, through bodily perfection. And then there is a mercury. So mercury is a very central element in ancient alchemy. It is known as parada. So it is seen as a divine living metal central to alchemical traditions. It is believed to absorb and transfer energy and essence. And then in the ancient times, during that alchemy actually, There were the preparation of elixirs and potent rasayanas using mercury and sulfur. Sulfur is known as gandhak. And then there was the development of plasmas and metallic medicines. And what was the legacy from the ancient knowledge of chemistry? What was the legacy? Rick's textual tradition. So there were those books, actually, the ancient books, Rasaratna, then Rasa Haridya Tantra. Those were the books. Influence on Unani and Arabic. So this knowledge from the traditional Indian knowledge system, actually transmitted to the Unani and Arabic, and even later on European alchemical practices. So from the knowledge of this Indian knowledge system, chemical knowledge was later on transmitted even to the Unani, Arabic, and the European alchemical systems. Because, and from this alchemical knowledge, so it served actually as a precursor to inorganic chemistry and nanomedicine. In modern terms, we call it as inorganic chemistry and nanomedicine. And then this is another contribution, the natural sources of colors. So in ancient times, ancient India, people knew how to use colors for different purposes. For example, indigo. Indigo is used for deep blue textiles. Turmeric is a haldi. You know that it is a haldi. It is common in all. It's a household item. It is extracted from curcuma. I'll come to that. One slide is there for curcumin later on. It provides a violent yellow color, and it has medicinal properties such as antimicrobial properties. And there is sindoor, and sindoor is known as, it is a vermilion. So vermilion is actually, it is known as cinnabar. Chemically, it is known as cinnabar, mercury sulfide. It is a very nice deep red color substance, and it is used as a symbol in rituals and cosmetics. In the ancient time, when sindoor was applied, it was this material actually, that cinnabar, known as vermilion. At that time, it was used as a sindoor. Nowadays, it has been actually replaced because of the toxicity concerns. Mercury is a toxic metal. Nowadays, it has been replaced with some safer alternatives. But earlier, it was the vermilion, that a mercury substance. Then the organic chemistry was also there. The people knew how to use knowledge of plant-based extractions, mordants, and fixatives. They knew how to use alkaline fermentations for indigo dyeing. They also knew how to apply metal salts such as alum, iron, and copper to modify and fix colors. And also, it was applied to cultural and artistic use. Intrinsically dyed textiles, manuscripts, temple art, and cosmetics. We can see nowadays all these things. Dyeing and pigment use mentioned in Vedic, Buddhist, and Sangam texts. And also those dyes actually that were prepared in ancient India, they used to be exported from India globally in the ancient world. There was that export of those dyes to the outside India actually for different purposes. Now, what is the scientific relevance today? Scientific relevance is that they are eco-friendly because they are made from, these dyes are made from natural sources. They are eco-friendly and they are biocompatible. They do minimum harm to the human body as well as other animals. And they're reviving natural dyes to replace synthetic, because nowadays people are very much concerned about synthetic things. Nobody wants to use synthetic things. Okay, but if you go to the textiles, they use all sorts of synthetic dyes, which is not good for health. Okay, so this is a kind of, in ancient India actually taught us how to use natural substances and natural and biocompatible substances for dyeing purposes, for coloring purposes. So this actually gave a hint to the early organic synthesis. Nowadays, there is a subject in chemistry called organic chemistry, which is a vast subject, and those hints actually came from early traditional, ancient Indian practices. And this is another area where the chemistry has a role in ancient Indian knowledge system, the perfumes and cosmetics. This is called, Gandhayukti, the science of scent. Okay, it is dealt in Kama Sutra. Then there is a technique for blending perfumes with botanical extract. There is a concept of harmonizing fragrance with season's modern personality. There is something called attars and essential oils, where people also prepare attars and essential oils by performing hydrodistillation. There's a technique now called as hydrodistillation, using natural things like rose, jasmine, and sandalwood. Okay? They used sesame oil or sandalwood as a base, and they were stored in special containers for maturation. Okay, so from these techniques, then people knew that the early perfume chemistry actually developed in India, and they have the understanding of the process of distillation. Distillation is now a modern technique, but it actually came from the ancient India. And they have the understanding of the volatile oils, solubility, and fixatives. And cosmetics and care also, if we see, then natural makeup from saffron, turmeric, and sandalwood was also there. Okay, if you can see here that there's turmeric, the haldi is used in marriage ceremony in India. Now also it is present. It is used and it's very good for skin. Those were the ancient knowledges actually now transmitted to the modern times. What is the scientific legacy of this all ancient knowledge? The precursors to modern perfumery and aromatherapy. Now it is the modern perfumery and aromatherapy. These are not scientific subjects now. Actually, these are all inspired by Indian knowledge system that was started in ancient times in India. Then this is another area where Indians have the great knowledge of chemistry, Indian glass and ceramics chemistry. The Indians, in ancient India, people knew how to do glass making. Because earliest glass beads dates back to the second millennium BCE, Harappan sites, found in Taxila also, known for colored glassmaking and intricate designs. They used plant ash as flax with silica-rich sand for low-temperature glass formation. And glass, ceramics, and pottery were also, that time was also people used to make all those things. And they use natural pigments and mineral glazes for coloration. They use metals like copper, cobalt, iron oxides to add color to the glasses and ceramics. They knew how to control the temperatures and atmospheric conditions to achieve the best results. And from this knowledge of the ancient times in India, we get insights like of materials chemistry. Nowadays, materials chemistry is a modern subject. So they get from the how the insights were came. It actually came from the ancient India. The understanding of glass forming network, silica is the main material in the glasses, and how to modify it using alkali metals to add colors. Then the use of lead, tin, borax, and all these things. And innovations in annealing and thermal shock resistance were also discovered in the ancient India. What is the legacy and impact? It is the contributions to the material science. So from this knowledge from the Indian, traditional ancient India, so people gain knowledge of the material science and ancient nanochemistry, influence on Islamic and later European glass tradition. Later on, it actually transmitted to Islamic and European glass making practices. And all these things actually give an example of the applied inorganic chemistry in art and daily life. Then there is another area where chemistry played an important role in Indian knowledge system, the development of gunpowder, pyrotechnics, and fireworks. So nowadays also these things are present. It originated in the ancient India in the time of Kautilya's Arthashastra, 4th century BC. They actually mentions recipes and military applications of explosives. And there is a references to Agni Karma, fire-based weapons in ancient treatises. Early use of combustible paste and smoke screens for warfare and signaling. And so in ancient India, they used mainly three types of things actually to prepare this type of gunpowder, pyrotechnics, and fire. What are those three types of things? One is the sulfur, known as gandhaka, and then charcoal. It is produced from dried woods act as a fuel, and saltpeter. Saltpeter is a chemical. It is known as potassium nitrate. It was obtained from salt leaches and animal dung piles. These three things they combine to use those gunpowder, pyrotechnics, and fireworks. And then there's all these things were used in ceremonial fireworks. Even nowadays people use in Diwalis and all. And then the use of natural dyes and metals to produce colored flames. Early development of rockets and flame throwing devices, for example, in Mysorean rockets. What is the scientific legacy? So though from this knowledge, so we got those inspiration, the motivation of the early roots of combustion chemistry. Nowadays, combustion chemistry is a modern subject, it's a fast subject, as well as thermochemistry. And also we get to know the precursors to military and celebratory pyrotechnics. And it actually demonstrates deep chemical understanding in the ancient time. In ancient India, what it demonstrates from the above examples above, that it demonstrates deep chemical understanding of chemical reactivity and energy release processes, which is central to chemistry nowadays. This is another area, food in Indian knowledge system. And people also had the chemical, they knew the chemical aspects of food in ancient India. They knew the fermentation technique, the ancient use of curd, idli, dosa, butter, you know, natural lactic acid fermentation process, the use of yeast and ambient microbes for controlled fermentation, for the purpose of enhancing bioavailability of nutrients and introducing beneficial probiotics. They also knew the preservation methods, sun drying, salting, smoking, and pickling techniques to reduce water activity. They knew the use of herbal antimicrobials like turmeric, mustard, fenugreek. Okay, then also that synergistic blends, we call it as masalas, help preserve food and improve shelf life. And then comes the chemistry of taste. Classical Ayurvedic concept, there are six rasas: Madhura, Amla, Lavana, Katu, Tikta, and Kashaya. So these are actually linked to modern taste receptor activation and nutrient balances. The taste is seen as an indicator of digestive and therapeutic properties. And then there is a nutritional and medicinal additives. People knew how to use nutritional medicinal additive. The addition of triphala, ginger, black pepper, cumin for digestion and immunity improvement. Use of alkalinity, lime water in dishes to aid absorption. And what is the legacy that is learned from this ancient Indian knowledge is that early functional and fortified food concepts. So people actually knew that the use of this early functional and fortified food concept, it came from ancient Indian knowledge, chemical knowledge, recognition of food as medicine, ahara as a pillar of health. And what is the modern parallel? Nowadays we have this very common, prebiotics and nutraceuticals, bioactive compound. All these things actually came from ancient Indian practices, deeply rooted in food chemistry. And also this is another area, another example of the area where chemistry had a role in religious and spiritual practices. For example, in Humayun Yagga rituals, offering ghee, herbs, food, and grains in sacrificial fire, generating these things actually generate aromatic compounds and fumigants. Then combustion of samida, specific woods and herbs like gugul, neem, sandalwood, releases phenols, aldehydes, and terpenes. It acted as an ancient form of air purification and microbial control. Then volatile oils and vapors enhance mental alertness, emotional balance. There is then there is something called incense, that hoop and agarbatti. There also their contribution chemistry is present. And then chemical symbolism in rituals. The camphor was used. It actually, camphor is a very common substance, chemical substance. It sublimates directly without from solid to vapor without going to a liquid phase. And then they have the knowledge of the sublimation chemistry. And turmeric and sandalwood used in tilak, rich in curcumin, cinnabar, symbolizing purity and protection. So from all these things comes the spiritual biochemistry, the knowledge of spiritual biochemistry, the rituals understood to affect the mind-body state through sensory chemistry. Uh, then this is the another contribution of the Indian knowledge system of chemistry. Those texts actually, the chemistry in ancient Indian text. One of the texts is this Rasaratnakara. This is a text actually written by Acharya Nagarjuna. So in this text, we find the details of those and the ancient chemical knowledges, chemistry knowledges. A seminal alchemy treatise deals with metals, minerals, and purification techniques. And detailed instructions on calcination, sublimation, and distillations are actually given in this book. And it describes the plasma preparation in the ancient time. It also emphasizes controlled heating cycles and the role of organic binders in herbal reagents. Then another one is the Saraka Samhita, where the concept, the classical text on Ayurveda, interwoven with chemical and pharmaceutical knowledge, and list of herbal formulations and mineral preparation and concepts of solubility, extraction, and preservation. In this book, actually, we find the Ayurvedic knowledge, the chemical aspects of the Ayurveda we find in this book. And then there is also these things are there, material science in philosophy. Ancient texts treat matter as a combination of Pancha Mahabhutas. And there was an early understanding of atomic theory, Anu, Paramanu. It emphasis on transformation, balance, and synergy, precursors to systems chemistry and green chemistry. All these things actually served as a precursor to what is now known as systems chemistry and green chemistry in modern chemical sciences. Okay, so I have discussed some of the examples in my previous slides. Now, if you compare this, traditional, ancient chemical knowledges with the modern chemistry, then we find that there are procedural similarities. One of the similarities is the shodhana. Shodhana is known as purification. So it is actually modern purification techniques are available like recrystallization and washing. So it actually came from that shodhana actually, that the ancient knowledge. Then puta is a calcination cycle, controlled, and it in modern chemistry it is known as controlled thermal decomposition in modern inorganic synthesis. Then Fasmikarana is the ash formation, and it is comparable to, now in modern chemistry, it is comparable to metal oxide preparations and nanoformulations. What is the empirical approach? Ancient alchemists practiced trial and error methods. So in ancient time, it was actually a trial and error method, which is a kind of tedious job. It was a cumbersome job. It was a trial and error method. They observed color changes, reactions to heat, and effects of solvents. And this is akin to actually similar to empirical testing in modern laboratory. And the use of standardized tools, yantras, reflects an early understanding of apparatus and instrumentation. Now that we have instrumentation, different types of apparatus and instruments available in chemistry laboratory. So in ancient time also it was there, known as yantras. Then controlled reaction. In terms of controlled reactions, in the ancient India, people knew how to stepwise add reagents and precisely, control the temperature. They knew the use of catalysts like herbal and mineral. And nowadays also in chemistry, you have to optimize the reaction conditions to achieve the best result. Documentation in texts like Rasa Ratnakara, just in a previous slide I mentioned. In ancient time also, there was a documentation of all this knowledge in text. Now we have all those laboratory notebooks and protocols are available in modern chemistry. So overall, if you see that Indian knowledge system, with reference to chemistry, it was a holistic yet scientific approach. Integrated philosophy, medicine, and material science is a kind of interdisciplinary approach. And there was emphasis on safety, efficacy, and reproducibility in ancient India. Now it actually translates to the good manufacturing practices in chemical industry. Now, if we want to rediscover these traditional formulations, the modern research on Indian knowledge system, specifically on chemistry. So there is a renewed scientific interest in herbomineral and plant-based formulations from traditional texts. So people are trying to see what is written on those traditional texts like Rasa Ratnakara. Okay, then try to find out some of the important information, then apply those knowledge in modern chemistry. A focus on standardization, safety, bioavailability, and mechanistic studies. The use of spectroscopy, chromatography, X-ray diffraction, then scanning electron microscopy, and cell-based assays to validate ancient preparations. All these sorts of things are going on in modern chemistry, where the knowledge actually came from ancient chemistry. For example, this is a case study one where Tinospora cordifolia is a kind of, it is a therapeutic formulation. It is traditionally used as immunomodulator, antipyretic, and detoxifier. In modern findings, it is people have done research. What is there in this Tinospora cordiafolia? People have found that it is rich in alkaloids, thioterpenoids, glycosides, and they are actually known to stimulate immunoresponse, potential in metabolic disorder and viral infections. And this is the case of turmeric. Turmeric has been traditionally used as anti-inflammatory, wound healing, and preservative purposes. And modern finding is that in turmeric, if we see, the active component is curcumin. Curcumin is the bioactive component of turmeric. And pharmaceutical studies have revealed that it has antioxidant, anti-cancer, and neuroprotective properties. And it can be characterized using nanoparticle gold with organic coatings. And bridging the gap. So if you want to bridge the gap between the traditional knowledge and the modern chemistry, the ancient formulations are becoming lead candidates in drug discovery. Nowadays, people are going back to ancient these chemical knowledges, and some of the things, some of the uh, chemicals that was discovered in ancient India has become lead candidates in drug discovery in modern chemistry or pharmaceutical chemistry. They offer a sustainable and culturally resonant part in green chemistry and pharmacology. I just want to specifically mention about the curcumin that turmeric, as you know, it is present from ancient India. It is a curry powder. We know that it is a household item. We use turmeric in all the preparations, in recipes. So the active component of turmeric is the curcumin actually. Curcumin is a chemical compound that has been isolated from turmeric. And if you see, it's now modern research has shown, chemistry research has shown that it has a plethora of therapeutic activities, starting from antimicrobial, antioxidant, anti-inflammatory, cardioprotective, neuroprotective, anti-cancer, hepatoprotective, all sorts of things are present. Okay, now in modern times also, this research in curcumin is a very vibrant area of research. For example, I show here one journal paper has been published recently, last month. SS Applied Materials Interface. It was published by my former PhD student actually, Dr. Sarkar. She is now working at Hyderabad. IICT. So she published this paper. She prepared some formulations using curcumin and manganese as a metal, and she showed that it is a very good combination to treat this lung cancer. She has done a lot of studies. So if somebody is interested, they can go through this paper. Even I also work on curcumin and its metal-based formulation eventually. Now, if we want to integrate this Indian knowledge system and chemistry, so what are the things we can do? So, as you know that NAP 2020, there is a policy push. There is a emphasis has been placed on Indian knowledge system. National education policy emphasizes integrating IKS into mainstream education. There is a attempt from the government to integrate IKS in mainstream education. It encourages interdisciplinary learning, blending modern science with traditional wisdom. And what is the institutional framework for this? Establishment of ICAS division. Nowadays, under the Ministry of Education, the different ICAS centers can be established over entire India. And then there is a support for interdisciplinary research, documentation, and teaching of traditional sciences. And center of excellences can be established across the IITs, NITs, and central universities that promote IKS-based science projects. And there is a need for curriculum reforms. Undergraduate and PG chemistry syllabus should include several universities. In the already it is there. Several universities now include this one. Rasa Shastra and Ayurvedic alchemy, traditional materials, osmosis, dyeing, natural surfactants, green chemistry practices, encouraging project-based learning. And there is an opportunity for students and scholars uh, fellowships and granted for IKS-based chemistry research. Online courses, workshops, and conferences can be organized. And science in ancient India, scope for innovation in natural product chemistry, sustainable technologies, and heritage science. And what is the relevant? It actually from if we integrate IKEAs with chemistry, so we build a sense of cultural pride because it is the Indian culture. We should be proud of this, and promotes contextual science education. It actually opens, more importantly, it opens avenues in drug discovery, material science, and environmental chemistry. I have only two, three slides, I think. And but if we want to integrate IKS with the modern science, so there are some challenges like scientific validation. Many traditional formulations lack standardized documentation. We don't have a standardized document in place. That is one challenge. And there is a need for rigorous clinical trials. Those ancient formulations, there are not many clinical trials available because clinical trial means pharmaceutical companies has to come out. They have to come up to do those clinical trials, but that is not happening right now. And there is a translating ancient terminology into modern scientific language is another challenge because those ancient terminologies were used, but how to translate those terminologies to modern scientific language can be challenging. And what is the skepticism versus evidence? Dominant narratives often view IKS as a non-empirical or pseudoscience. So they feel that Indian knowledge system is not a pure science; it is a kind of pseudoscience. And there is a historical bias against non-Western systems of knowledge. So some people outside India may think that is a kind of bias. Then the challenge is to balance balancing the respect for tradition with demand for scientific scrutiny. Preservation of traditional knowledge. The risk of losing oral and manuscript-based knowledge. This risk is there. Limited number of trained scholars proficient in Sanskrit, regional language, and traditional sciences. Then there's problem with intellectual property and ethics. There's a threat of biopiracy and exploitation of community health knowledge, lack of IPR frameworks to protect traditional science innovators, importance of ethical collaboration with traditional practitioners. What are the institutional barriers? There is limited space in current curricula for IKS-based courses, the scarcity of funding and trained faculties for IKS science interface, and there is a need for policy reforms also. And these are some of the future prospects. For example, sustainable chemistry can be developed from Indian knowledge system, like low energy, eco-friendly, biodegradable things can be developed, and waste generation can be minimized, and it can be aligned with the United Nations Sustainable Development Goal. And then we can bridge actually those ancient knowledge with the current this one material sciences like nanotechnology. Then green chemistry inspiration can be inspired if somebody is working green chemistry. Those inspiration can be obtained from the ancient chemistry. What is the global relevance? India can take the lead in showcasing how ancient wisdom meets modern science. There is a scope for collaborative innovation hubs that combine traditional knowledge with modern lab techniques. And this is the conclusion. The summary of the Indian knowledge system contributions to chemistry. Historical depth, there is historical depth, consensus of applied chemistry in metallurgy, medicine, alchemy, and materials. Multidisciplinary insights, integration of natural products, material sciences, and spiritual understanding. Innovations in fermentation, distillation, dye extraction, cosmetics, and metallurgy. Then those fundamental texts are also available in Indian knowledge system related to chemistry. IKS offers a sustainable, holistic perspective in contrast to resource-intensive models. So bridging traditional knowledge with scientific validation can unlock new discoveries and ethical practices. NAP 2020, educational integration, ensures cultural continuity and innovation. And then some of the points like how we can ensure authentic yet scientific reinterpretation of Indian knowledge system. What are the ethical boundaries in commercializing traditional formulations? Can you create syllabus and lab models that teach both modern and IKS chemistry? These are open questions that remains to be discussed. And thank you for your kind attention. Finally, thank you very much.